IDMS Online Training. Introduction to IDMS Training. Integrated Database Management System (IDMS) is a hierarchical database management system (DBMS) primarily used for mainframe environments. It was developed by Computer Associates International Incorporated (CA) and is designed to manage large amounts of data efficiently and effectively. IDMS supports both network and hierarchical data models, making it versatile for various applications. Training objectives. The IDMS training program aims to provide participants with the knowledge and skills necessary to effectively use and manage IDMS databases. The training will cover understanding IDMS architecture, overview of IDMS components, including the database structure, data dictionary, and access methods, understanding the network and hierarchical models used in IDMS, installation and configuration, steps for installing IDMS on mainframe systems, configuration settings to optimize performance and security, database design and management, principles of designing an IDMS database, creating and managing data structures, including records, sets, and schemas, data manipulation, introduction to IDMS commands and languages such as DML, data manipulation language, performing data retrieval, updates, and deletions, performance tuning, techniques for optimizing IDMS performance, monitoring and troubleshooting performance issues, backup and recovery, strategies for backing up IDMS databases, recovery procedures to ensure data integrity, security and access control, implementing security measures to protect data, managing user access and roles within IDMS, application development, integrating IDMS with programming languages, example COBOL, PLI, building applications that interact with IDMS databases. Target audience. The IDMS training is ideal for database administrators, DBAs, looking to enhance their skills in managing IDMS databases, application developers seeking to integrate IDMS with their applications, IT professionals who need a foundational understanding of IDMS for support and maintenance. IDMS Architecture Overview. IDMS, Integrated Database Management System, is a hierarchical database management system that was developed by Computer Associates, CA, in the 1970s. IDMS is primarily used in mainframe environments and supports applications that require high performance and scalability. Below is an overview of its architecture, components, and features. IDMS Architecture Overview. 1. Architecture Components. Database Structure. Hierarchical Organization. IDMS organizes data in a hierarchical structure using records and sets. Records represent individual data entities, while sets define the relationships between these records. Physical and logical structure. The physical structure includes the storage format, while the logical structure defines how data is accessed and related. Data Dictionary. IDMS maintains a data dictionary that stores metadata about the database structure, including record types, set structures, and access methods. This is critical for data integrity and management. Access methods. IDMS supports various access methods for data retrieval and manipulation, including navigational access through record sets and SQLi query capabilities, SQLDB, for standard query operations. Buffers and caching. The architecture utilizes buffers to improve performance by caching frequently accessed data in memory, reducing the need for disk I/O. 2. Processing layers. User interface layer. Users interact with the system through application programs, which can be written in various programming languages. This layer can also include graphical user interfaces, GUIs, for better user experience. Application layer. This layer contains the business logic and application programs that define how data is processed. It communicates with the database to perform operations like inserts, updates, and deletes. Database layer. The core IDMS database management system resides here, managing data storage, retrieval, and integrity. It is responsible for processing database requests and ensuring data consistency. 3. Database management features. Transaction management. IDMS supports ACID, atomicity, consistency, isolation, durability, properties to ensure reliable transactions, providing mechanisms for commit and rollback operations. Concurrency control. It uses locking mechanisms to manage concurrent access to data, preventing conflicts and ensuring data integrity. Backup and recovery. IDMS includes features for database backup and recovery to protect against data loss. This can involve both online and offline backup strategies. Security. Security features include user authentication, role-based access control, and auditing capabilities to protect sensitive data. Data modeling in IDMS training. Data modeling in Integrated Database Management System, IDMS, involves the creation of data models that define how data is structured, stored, and accessed within the IDMS environment. Training in this area typically covers several key components. 1. Understanding IDMS architecture. Overview of IDMS components, DBMS, network model, and transaction processing. Differences between hierarchical, relational, and network database models. Understanding the IDMS data dictionary and its role in data management. 2. Data model design. Concepts of data modeling, entities, attributes, relationships. Techniques for designing conceptual, logical, and physical data models. Best practices for creating data models that optimize performance and maintainability. 3. IDMS data definitions. Creating data definitions using IDMS language, DML. Understanding record types, set types, and schema definitions. Defining constraints and integrity rules within the IDMS environment. 4. Mapping data models to IDMS. Techniques for translating logical data models into physical models specific to IDMS. Defining hierarchies and networks in IDMS. Mapping entities and relationships to IDMS structures. 5. Data manipulation and querying. Using IDMS DML for data manipulation, insert, update, delete operations. Writing queries using IDMS SQL for data retrieval. Understanding performance tuning for queries and data retrieval. 6. Normalization and denormalization. Concepts of normalization and its importance in database design. When and how to denormalize data in IDMS for performance considerations. 7. Security and integrity. Implementing security measures within IDMS data models. Understanding how to enforce data integrity and consistency in the database. 8. Case studies and practical exercises. Real-world scenarios for practicing data modeling in IDMS. Hands-on exercises in building data models and working with IDMS tools. Best practices from industry examples. 9. Advanced topics. Exploring advanced data modeling techniques such as dimensional modeling for data warehousing. Integration of IDMS with other databases and data sources. Understanding modern trends in database management that may impact IDMS usage. IDMS DML and DDL operations. Integrated Data Management System, IDMS, is a database management system, DBMS, that uses a network model to manage data. IDMS supports both data manipulation language, DML, and data definition language, DDL, operations. Here's an overview of both. DDL operations in IDMS. Data definition language, DDL, is used to define the structure of the database, including schema creation and modifications. In IDMS, DDL operations include create, used to create database objects such as tables, views, and schemas. For example, create schema schema_name. Create table _name, column 1 data type, column 2 data type. Alter, used to modify existing database objects. This can include adding or dropping columns from a table or modifying constraints. For example, alter table_name at column_name data type. Alter table_name drop column_name. Drop, used to delete database objects. For example, drop table_name. Drop view_name. Define, in IDMS, the define statement is commonly used to specify records, fields, and their properties in the database. For example, define record_name. Define field_name in record_name. Modify, used to change the definitions of existing records or fields within the database. DML operations in IDMS. Data manipulation language, DML, is used for managing data within the database. DML operations in IDMS include insert, adds new records to a database table. For example, insert into table_name, column 1, column 2, values, value 1, value 2. Update, modifies existing records in a table. For example, update table_name set column 1 is equal to value 1 where condition. Delete, removes records from a table. For example, delete from table_name where condition. Fetch, retrieves records from a database. It can be used in conjunction with cursors to fetch multiple records. For example, Fetch cursor_name into variable_list. Retrieve, specific to IDMS, this operation retrieves records based on specified criteria. It's similar to SQL's select statement. For example, retrieve record_name where condition. Commit rollback. These commands are used to control transaction management. A commit saves all changes made during the current transaction, while rollback undoes changes. Advanced query techniques in IDMS training. Advanced query techniques in Integrated Database Management System (IDMS) training typically encompass a range of skills and methodologies that enable users to effectively retrieve and manipulate data within IDMS databases. Here's an expanded outline of key areas covered in such training. 1. Understanding IDMS query fundamentals. Overview of IDMS architecture and its components. Basics of IDMS database structure, records, sets, and subschemas. Importance of efficient query design and execution. 2. Advanced query language. Detailed exploration of the IDMS SQL syntax. Use of advanced SQL features such as joins, inner, outer, cross, subqueries, correlated and uncorrelated, common table expressions, CTEs, window functions, row_number, rank, etc. 3. Optimizing query performance. Understanding the query execution plan. Techniques for indexing to speed up data retrieval. Use of statistics to analyze and improve query performance. Identifying and resolving bottlenecks in query execution. 4. Data retrieval techniques. Utilizing select statements effectively. Implementing distinct, group by, and having clauses for data aggregation. Employing order by for sorted result sets. Using fetch first and offset for pagination. 5. Data manipulation techniques. Advanced insert, update, delete operations. Using merge statements for upserts, insert or update. Bulk operations and their impact on performance. 6. Complex query scenarios. Handling hierarchical data retrieval using recursive queries. Leveraging stored procedures and functions for complex logic. Dynamic SQL, writing queries that can adapt based on parameters. 7. Error handling and debugging. Techniques for debugging complex queries. Common error messages and their resolutions. Best practices for error handling in IDMS. 8. Security considerations. Understanding user roles and permissions in IDMS. Performance tuning in IDMS training. Performance tuning in Integrated Database Management System (IDMS) training focuses on optimizing the efficiency and effectiveness of IDMS databases. This process is crucial for ensuring high performance and reliability in transaction processing and data retrieval. Here are the key components and areas covered in IDMS performance tuning training. 1. Understanding IDMS architecture. Overview of IDMS components, database, access methods, etc. The role of the IDMS Centralized Database, CDB, and DC, Data Communications, components. Transaction and Program Management in IDMS. 2. Database Design Principles. Best practices for data modeling and schema design. Importance of normalization and denormalization. Techniques for partitioning and indexing to enhance performance. 3. SQL optimization. Analyzing SQL queries for performance bottlenecks. Utilizing execution plans to understand query behavior. Techniques for rewriting queries for better performance. 4. Resource management. Monitoring system resources, CPU, memory, disk I/O. Managing and configuring database buffers and caches. Understanding and configuring IDMS system parameters. 5. Concurrency control. Techniques for managing concurrent transactions. Understanding locks, deadlocks, and isolation levels. Optimizing transaction throughput and response times. 6. Performance monitoring tools. Using IDMS monitoring tools to track performance metrics. Setting up alerts and reports for performance indicators. Understanding how to analyze performance logs. 7. Troubleshooting techniques. Identifying common performance issues and their causes. Utilizing diagnostic tools to troubleshoot problems. Implementing corrective measures and monitoring their effectiveness. 8. System maintenance. Scheduling regular maintenance tasks, reorganization, backups. Understanding the impact of maintenance on performance. Planning for system upgrades and migrations to maintain performance. 9. Performance testing. Analyzing performance testing results to identify areas for improvement. IDMS backup and recovery strategies. Implementing effective backup and recovery strategies for Integrated Database Management System (IDMS) is crucial for ensuring data integrity, availability, and minimizing downtime. Here's an expanded overview of key strategies. 1. Backup strategies. A. Full backup. Description: a complete copy of the entire database, including all data files, logs, and configurations. Frequency: typically performed on a scheduled basis, example weekly or monthly. Benefits: simplifies recovery since all data is contained in a single backup. B. Incremental backup. Description: only captures changes made since the last backup, either full or incremental. Frequency: often scheduled daily. Benefits: saves time and storage space compared to full backups. C. Differential backup. Description: backs up all changes made since the last full backup. Frequency: can be scheduled daily or multiple times a week. Benefits: restores faster than incremental backups, as it requires only the last full backup and the latest differential. D. Hot backup versus cold backup. Hot backup takes place while the database is still operational, allowing users to access data during the process. Cold backup requires the database to be offline, ensures data consistency but limits access during the backup process. 2. Recovery strategies. A. Point-in-time recovery. Description: allows restoration of the database to a specific moment, often used in the case of data corruption or accidental deletion. Implementation: combines full backups with transaction logs to replay or roll back transactions to the desired point. B. Data restoration testing. Description: regularly testing backup files to ensure they are valid and can be restored without issues. Frequency: recommended at least quarterly or after significant changes to backup procedures. Benefits: identifies potential problems before an actual disaster occurs. C. Disaster Recovery Plan, DRP. Description: a comprehensive plan that includes procedures for data recovery in the event of catastrophic failure, example, natural disasters, hardware failures. Components: risk assessment, identify potential risks and their impact. Response strategies, develop procedures for backup restoration and alternative operations. Communication plan, outline how to communicate with stakeholders during an incident. Why choose Proexcellency for IDMS Online Training? Choosing Proexcellency for IDMS, Integrated Database Management System, online training offers several advantages. Expert instructors: Proexcellency typically employs industry experts with extensive experience in IDMS, ensuring that participants receive high-quality instruction. Comprehensive curriculum: their training programs usually cover a wide range of topics, from basic concepts to advanced features, providing a thorough understanding of IDMS. Flexible learning: online training allows you to learn at your own pace and schedule, making it easier to balance your studies with work and personal commitments. Hands-on experience: Proexcellency often emphasizes practical training, providing hands-on labs and projects to help reinforce theoretical knowledge. Support and resources: participants usually have access to additional resources, including study materials, forums, and one-on-one support, enhancing the learning experience. Certification preparation: their training may include preparation for relevant certifications, which can help boost your professional credentials. Positive reviews and success stories: many students share their success stories and positive experiences, which can give you confidence in the quality of the training. Networking opportunities: engaging with fellow learners and instructors can help build a professional network in the IDMS community. Thank you.